Welcome, everybody. Thanks for joining us for our fourth virtual demonstration event hosted by the TURA program, showcasing a Massachusetts business that is implementing a toxic use reduction project. The reason that TURA hosts these demo events is to encourage other companies to reduce toxic chemical use. We're hoping that you learned something today that you can apply either to your facility or to your clients' manufacturing operations. Aero has worked with the TURA program in Massachusetts for many years. This year, they received a TURA industry grant in fiscal year 21 to assist with the purchase of a new degreasing system at their facility to eliminate the use of NPB. NPB is a listed higher hazard substance under the TURA program in Massachusetts and is therefore reportable. If you're outside of Massachusetts, don't worry about it, or you can look into more information about that requirement. Our main focus today is to hear from Aero about their implementation of their project, but we're also going to include some other background information to help you understand other parts of the project that went into making this happen, because these projects can take a lot of time to research and implement, and we want to recognize that and give you background information to help explain it. First, we're going to hear from Jim Cain with the Office of Technical Assistance, which is part of the TURA program, and he's going to give the history of their work with Aero and give some information about their organization. Then we're going to turn the presentation over to Ken Barron, who's a senior engineer with Aero, to really walk us through the details of the project. And within that, we're going to turn the presentation over to Alicia McCarthy and Haley Hudson with the TURA Cleaning Lab to talk about their roles in the project, which included lab testing of the potential alternatives, as well as environmental health and safety evaluation of the chosen alternative. So with that, we're going to start with Jim Cain.
As Joy said, OTA and TURA have worked with Aerovox, now Aero, for the last 25 years. You know, we were all much younger then. But I'm Jim Cain, one of the engineers at the Office of Technical Assistance. The chemical use fees support our program, so we can provide at no charge technical and compliance assistance to the manufacturers, businesses, and institutions. We don't enforce regulations. However, a lot of times we're asked to help interpret them. OTAs strive to suggest facility-specific and appropriate recommendations for TUR, resource conservation, energy, water, and other resources. And we have a lot of experience doing that. Next. I first met with Aerovox in 1995 when there were new regulations by the federal government for vapor degreasers with a number of compliance options and combinations, kind of complicated. This led to them purchasing a vacuum vapor degreaser that could reduce their emissions by up to 90%. 10 years later, we met and discussed some safer cleaning alternatives, and we're referring them to the TURA lab where they tested a number of things. Aqueous cleaners at that time weren't able to clean all their dielectric oils, and kind of went on from then. The recent years, we met and then referred them to again to go to the TURA lab, and they had some new oils and dropped some old oils that they were using in the past, and there were new cleaners available. So this time, I think we met with success, and hence this demo.
Thank you, Jim. And now we're going to turn it over to hear from Ken Barron from Aero.
Hi, I'm Ken Barron. I'm from Aero. I'm the manufacturing engineer over here. I've been working for Aero for about 40 years. We employ 80 people. Our facility on the manufacturing floor is 60,000 square feet, and the office space is 12,000. We've been in business for over 100 years. We've gone through several names. RTE Aerovox, Aerovox Inc., Aerovox Corporation. Now we are Aero. On the bottom of the screen, you can see our building. And to the right of that, we have an assembly worker putting a section pack assembly together. We manufacture capacitors over here, all types of capacitors. We do medical, military, health and beauty. We do variable speed controls. We do health and beauty products, power factor correction products. We do dry capacitors and wet capacitors. Our wet capacitors, we impregnate with oil. Okay, this is what a kind of capacitor looks like. We have a cover with terminals on it. This is a metal can. That one's made out of aluminum. We were operating a vapor degreaser. We were using n-propyl bromide for the cleaning solvent, and we had fugitive emissions of 5,600 pounds. And we had to maintain 10,000 pounds in our Aero degreaser system just for it to work correctly. But we got a new owner a couple of years ago, and he wanted us to switch from n-propyl bromide to an aqueous system. So we took opportunity and ran with it. Because of the health issues and the environmental concerns, we felt pretty confident that we were going to come up with a system that would benefit everybody over here and also the environment. You can move on. Okay, now, things we had to do to make this happen was, what are we going to use to clean? What chemistry are we going to use to clean in an aqueous system? So we called upon TURA Lab, and they did a lot of testing for us. We also had some of the equipment manufacturers do some testing for us, and they sent us the parts, so we give them, you know, what we liked, what we didn't like. But we kind of relied on TURA because they also looked at the dangers in the different chemistries we were using. So we got quotes from vendors for the equipment, and you can move on.
So thanks, Ken. That's a great introduction to the issue that you were dealing with at CD Aero. And so now I'm going to ask Alicia McCarthy to join us, and she's going to speak more specifics about that TURA lab testing process.
Yep. Thank you so much, Joy. So one of our first steps that we actually did before even this testing was we used our website that we have that is publicly available for you to use, which is our Cleaner Solutions database. And from there, we actually looked at different type of aqueous options that we could test in-house after getting samples from different vendors. So the ones that you actually see here, based after testing where we tried all the different types of contaminants that CD Aero was trying to remove, we actually found that one of them, specifically the epoxide soybean oil, was the hardest one to remove, which would take about 30 minutes. And the other three different types of oils took about 15 minutes to remove. So the overall effectiveness that you're seeing for each of these cleaners are actually looking at all of those different contaminants and how they overall were effective with removal with these different types of cleaners. And we found that it just needed air dry. So this was like our baseline of understanding of what worked on their contaminants for them. And that way they could see that there were options out there that could work for their process. Next slide. Later on, as we were working with CD Aero, they actually came up with what type of equipment they were starting to want to adopt. So we kind of changed our process based off of that, where they were looking more at it was going to be a conveyor belt with a new spray cleaning system. So we had to calculate how long these cleaners would take to be able to come in contact with the parts to remove those different contaminants. However, in our lab at that time, we didn't have a high pressure spray that could simulate exactly that. However, we could look at the chemistry itself just to see how it did alone. And you can see here, this is just the chemistry alone working on all those different types of contaminants, specifically, as I mentioned, the soybean oil being the hardest one to remove with just a 1 minute contact time. That's what we calculated with a 1 minute DI water rinse and then a 1 minute air dry. And without even the high pressure application, you can see we're already seeing over 50% removal up to the high 90s, especially for when it comes to the ceramic parts. So aluminum was actually one of our harder ones to remove. And these were the types of aqueous cleaners that they were interested in at that time period. Next slide. And what was nice about this too was as CD Aero was trying to figure out what type of aqueous cleaner they wanted to go to, they were working with vendors, and we were able to take in samples as they became interested in specific types, like this one, Aqueous PL 732. We did internal testing for them. They just had the samples sent to us, and we performed that testing with those same 1 minute contact, 1 minute DI water rinse, and 1 minute air dry. And all of this was done gravimetric removal. So we would have coupons or flat substrates specifically when we were starting off, where we would test it while it was clean, contaminate it with the amount of oil that would be on the surface area, and then cleaned it afterwards. The parts themselves were tested in-house more with CD Aero. And you can go to the next slide. So overall, looking at the specific alternative that CD Aero was interested in adopting, you can see there's variance in what worked and what didn't work on different types of substrates. But just because it didn't work in the lab doesn't always mean that it's not going to work in practice. As I mentioned, we didn't have that high pressure spray application. And so this is why it's really important where when you're testing the chemistry itself, you need to think about the equipment that you're going to adopt. So that's kind of where we were at. We gave this information to CD Aero, and they worked with the vendors to implement this and with OTA.
Great, thanks, Alicia. So now Haley's going to join us, and she's going to talk about TURA's tool to evaluate the EH&S profile of the alternative chosen.
Thanks, Joy. So we use TURA's hazard assessment tool, P2 OASIS, or the Pollution Prevention Options Analysis System, to compare CD Aero's original solvent to the aqueous alternative. P2 OASIS evaluates chemicals on 8 primary categories of environmental health and safety endpoints, each of which that can be expanded to about 150 data points. Once a level of acceptable data is entered, a summary score is generated ranging from 2 to 10, 2 being low or green, and 10 being very high concern or red. Each of the 8 main categories are scored in the same way, so you can identify what specific hazards might be driving the overall score. As you can see, switching to AquaEase from NPB is a major improvement. NPB has very high categories as it's anticipated to cause cancer and other chronic health effects, such as reproductive and neurotoxicity. It's also a hazardous air pollutant and harmful for the environment and wildlife. AquaEase does not have any categories with very high concern. AquaEase is an alkaline aqueous phosphate-based cleaner, and the only hazard really associated with it is mild skin and eye irritation.
Great, thank you, Haley. All right, so that we're going to turn back over to Ken to talk more about the project from their end.
Thank you, Joy. So we looked at the solution. We ended up looking at several cleaning systems, and we went with a company called GemFab. And we're using the new cleaner, the AquaEase PL732 detergent, and that's a 55-gallon drum you see in front of you. It's manufactured by Hubbard Hall. Hubbard Hall is where we used to actually purchase our MPB from. And Tori was happy with this product, so we ran with it, and we're using it as we speak. Move on, please. Okay, some of the obstacles we ran into was to try and find the right chemistry for this equipment. And of course, we thank Tori for all the help you gave us and the manufacturers of the equipment for actually doing some testing for us as well. But whenever we get new equipment over here, we have to qualify it. It's a rigorous process. And because it's a slow process, we have to put a lot of things in place. So we charge the machine up with the water and the chemistry, and we do some things, you know, work on the qualification, and everything's just sitting there. So we were building up bacteria inside the equipment, so we have to actually clean that out with a product called AccuPure OXP. And ever since we did that and we flushed the system out really, really well, we haven't had any issues whatsoever with that type of a problem again. We also dealt with delays due to COVID-19. In fact, when we had to do the factory acceptance test, 4 of us were supposed to go over there and evaluate the performance. Only 1 of us were willing to go there. That was our operations manager. And of course, we had to put a capital cost together and sell it to the company, which I really wasn't concerned with since our new owner wanted us to switch over anyway.
Ken, before I move on, could you just lean into your mic a little bit more so it's a little bit clearer to hear you?
Okay, I'll just, okay.
Perfect, thank you. Okay,
And
so now,
say it again?
Yeah, I'm gonna show a video and Ken's gonna speak to that video along the way. Ken, just tell me to pause if you need me to pause.
Okay. Okay, over here, what we're doing, we have an assembly line. They're actually, looks like they're soldering some tabs and wires on sections. You really can't see the sections. This lady's actually putting a section pack together. She soldered all the sections together, and now it looks like she's working on the wire leads. She's doing some insulation on the individual section packs, and she's checking to make sure she did a good job. Everything is insulated, so there's no shorting going on between the capacitors. This is our tank room. What you're looking at is our impregnation tanks, our wet products.
Sorry, my bad.
Okay.
Keep going, keep going.
Well, you're back at the beginning.
Yeah, sorry. Okay.
Okay, this is our impregnation. These are our impregnation tanks where we put our products in so we can impregnate them with the various oils. That's Victor loading baskets with capacitor cans into them, into one of the tanks. And he fills those tanks up, and then he closes the cover. We go through a vacuum, hold it a minute. We go through a vacuum, a drying cycle, a vacuum cycle. Then we impregnate it with oil. This is a 55-gallon drum of the actual chemistry we use in our new Aqueous system. And again, it's made by Hubbard Hall. Okay, in the background is our actual washer made by Genifab. That's Victor walking up to it. He's going to start loading some products into it. This is the wash and rinse tank side of the machine. This is the HMI. This is the controller that operates the machine. We control the temperature and the of both tanks and the hot air blower. You can start it. This is Victor loading capacitor baskets with capacitors into the washer. As you can see, it doesn't take a lot of effort to do that. The old system was a real bear with a batch system. So we had to do a lot of labor just to get the parts into them. Okay, this is a basket going into the washer. It's a conveyorized washer, so it's automated, fully automatic. This is the blower part of the machine where we send high volumes of hot air to dry off the capacitors, so when they come out, they're bone dry. This is the conveyor on the manufacturing side. After the products have been cleaned and dried off, and we even cool them down. That's just one of our capacitors standing up. In the background, there's a machine over there. It's a black in color. That's the actual final test machine where the product goes through. Again, this is Genifab washer, another angle. Looks like the video stopped. Okay. All right. So to break down our capital cost, the grand total for this entire project was $260,000. This included the power conveyor, the water evaporator we use. We take all the wash water from the washing pass-through conveyor every 3 weeks, and we put it in a holding tank, and we transfer that dirty water into a water evaporator, which evaporates all the water and all the leftover oil and contaminants we clean out of the water evaporator just so often to keep it clean. This also includes the freight cost, the rigging, the installation of the new equipment, the removal of the old equipment, and of course miscellaneous and contingency. We applied for a grant with TURA, and we were awarded a $30,000 grant, so that brought the grant total down to $230,000. Thank you. Okay, so we looked at the annual operating cost to compare one to the other. And at first, we wanted to just replace our environmentally unsafe system with the Aqueous system. We weren't expecting a payback, but when we analyzed our annual operating costs, we actually end up with a cost savings. We compared using the cleaning solutions. That was a wash. It was both $15,000 a year. The electricity that we use on the old system was $56,500. On the new system, it's $35,500. So we have a cost savings there. The steam on the old NPP system, we were spending $25,500 a year, and we went down to $11,000 on the new system. The water, we didn't use in the old system, but we're paying $1,000 a year on the new system. The impregnation oil that we use, that we have to dispose of as a wash, because that hasn't changed. We don't have to report anything like we did with the MPP. We had to report, it would cost us $1,200 a year. We had to report to TURA. That was a fee every single year. And the maintenance costs on the old system, because we were always replacing components and what have you, cost $11,000 a year, and we're not really spending anything on the new system. So our grand total cost savings was $46,451. Okay, back when, 21 years ago, when we started using the MPP system, it took several weeks of training because there was a lot of buttons and doors to open, a lot of valves to operate manually. The new system, it took us about 30 minutes per employee, and there was only 4 or 5 employees we had to train, so there was nothing there. The throughput on the old system was about 40 baskets. On the new system, it's 68 baskets, so it's over a 50% increase in throughput. Maintenance labor on the MPP system was 3 hours a week, and it's just under 2 hours a week, and that's just to clean out the system and replenish it with new chemistry and water. PPE was the same, just gloves and goggles, of course, with the COVID thing, the mask as well. Okay, so payback calculation, not using the TURA grant into consideration. The capital was $260,000. Our savings was $46,000. So we're getting, this machine is paying for itself in 5.5 years. We also added benefits. We also freed up 1,920 square feet, which we're moving our stock room to the area where the NPP system was. And we're using the space from the stock room into manufacturing space, and that's worth, manufacturing space is worth a lot more than a square foot of warehouse space, so we're saving another $16,000 a year. We don't have to worry about a carbon absorption system anymore because we don't need it with the Aqueous system. The workers are very, very happy with the health and safety concerns, and it's a lot easier, as I mentioned before, to operate this equipment. And the equipment manufacturer actually asked us if we could actually, if they could actually send some of their people over here so they could see our machine in operation because it's working so well. And if you have any questions, feel free with any of these people, actually.
Thank you, Ken. Thanks so much for presenting the information. Let's see, I'll just start with, we had a question earlier about the way that the lab did their testing. I hope that was clear. Alicia explained it quickly. They use coupons in the lab, little rectangles of the substrate, the aluminum or the ceramic, and they dirty them up like it would be with the part. And then they weigh it before cleaning and after cleaning to get the difference in weight. And that's how they got that percentage effectiveness that was shown in those tables. If that doesn't make sense, please ask another question. And then we have another question now. How long did it take to implement with this new equipment, Ken?
It took us about 6 to 8 weeks. Like I said, there was a lot of stuff going on. The qualification, because we have a lot of medical customers and everything has to be approved by the FDA. And they actually have special documents that they sent over to us that we had to actually, it was a project. We had to actually do a lot of things we would have normally never thought of doing with the equipment because they have to sell this to the FDA. So it took a few weeks to get this going. Plus, in the meantime, we were still playing and experimenting with the new equipment while we were still running the MPP system. So it wasn't until we were absolutely positively sure that this system was the only thing we needed to get all our products clean and out to our customers before we started tearing the old system apart.
Yeah, and I could just add from TURA's perspective, they applied for a grant, I guess in the spring of 2019, and then it was over the course of the next 10 months at least that they were still getting vendor quotes, verifying the Aqueous alternative and actually getting the equipment in-house and implementing, Ken, right?
That's cool.
Yeah. Any other questions?
I have a question, Ken. If you go back to the operating expense chart, thank you. So it's really interesting. This is a really interesting, example of what the impact on costs were. And one of the biggest cost changes were the electricity and steam associated with running the two systems. Can you just kind of go in a little more detail as to why those were reduced so significantly?
Okay, the electrical part of it, if you saw our MPP system that was manufactured by Zurich, it was a monster. It took up, like almost 2,000 square feet. There were a lot of valves on it. There was a lot of motors on it. The conveyor system, there were two conveyor systems because it actually had two tunnels. Like I said, it was a batch system. So you'd load one up and a half an hour later, you'd load another one up. And, all these doors and valves and switches and motors. I mean, it used up a lot of electricity in kilowatt hours. So that's why the electrical cost was so much higher than the GenFab Aqueous pass-through washer conveyor. And on the steam, it only used, the new system only uses like 924 pounds per hour. And the old system, like I said, was the system was so much larger, it needed a lot more steam to keep the heat up. I hope that answers your question.
No, that's really helpful. I mean, because that was a bit of a surprise, I think, for me anyway. I have a couple of questions here. One is just how many hours per year do you think the system will be operating?
Hours per year. I would say around between 1,500 and 2,000.
So similar to the old system, or will you be able to operate it more? Will you need to?
No, I think it'll be less than the old system because we're able to pass through more production on the new system than we were in the old system.
That's really great. Was there any labor savings to operating the new system versus the old system?
Yes, because the old system was slower, we actually operated on 3 shifts. We mostly do all our washing on the first shift now. Very little is done on the second shift. I don't believe anything is done on the third shift at all.
That's great. So those are, there's a lot of sort of unexpected benefits coming out of this switch, which is nice. And
things I didn't see at first.
I'm sorry?
Things we didn't see at first came out, and we were quite happy with the results.
Right. And that's actually a a really important message for the rest of us, because when you just look at the quantifiable, operating costs versus the capital cost, you're looking at 5 or so years payback, but these other factors start to really make that calculus a lot more favorable for you. Let's see, we have a question here about the types of oils that you're using. Is there any opportunity to change? Have you tested different oils that might be easier to clean when you're impregnating?
Yes, I mean, the oils we're using right now are not exactly the same oils we used 20 years ago. We do have another oil we use, which is the silicone oil. We do not actually impregnate capacitor cans with that type of an oil, but we do individual sections that we use in our dry products. Our dry products, the sections are impregnated in silicone, and they're put into plastic cases, and instead of an oil fill unit, we put epoxy in there.
Mm-hmm.
So it's a dry unit.
Mm-hmm. Right.
And that's the only other oil we use.
That's another way of approaching toxic use reduction, is to look at why you need the chemical that you're using, and see if there's changes that you can be making upstream that might make it less, that would require less use of that cleaning chemical. So while what you did was to replace the solvent with an aqueous cleaner, which is great, another technique that a planner might look at would be, is if we move to a different oil, would that also help to reduce the amount of cleaning that would be required? So that's why we were just asking that question, I think.
And I was just going to add too, Alicia mentioned in the chat, but when it comes to the lab testing, they contaminate their coupons with whatever oil is used, but that's also a place where you can test a different oil on the substrate and then try it with the different cleaners to see if it's, makes any difference for the facility to think about switching oils.
Well, it doesn't matter what oil we would ever come up with for our capacitors. We would still have to clean that residue off the capacitor cases.
Mm-hmm.
So I don't think any oil would prevent us from cleaning anything.
Right. It might be easier to clean or something, but I'm sure that has already been kind of looked at. We have a question for you, Ken, about whether switching to this new system had any additional permitting issues for you. Did you have to, did you have any permitting that you had to do with the state or with your town to switch to this aqueous system?
None whatsoever. They just gave us the guidelines of how we dispose of the dirty solution. And they were happy with our methods with the wastewater evaporator. And we're able to actually drain our rinse tank water into the city sewer. We have permission from, Geo Insight.
Mm-hmm. So that's great that you're able to do that, discharge directly to the publicly owned treatment works. I have a question here. So how does the saving of space turn into a $16,000 benefit to you? Is it that you're able to manufacture more products?
Yes, the value of a square foot of manufacturing space is a lot higher than warehouse space.
So there's some value associated with square foot of manufacturing.
Correct. Correct.
Yeah. Can you talk a little bit more about like the space that the old system took up at your facility? Because I saw it when it was the old thing, and now we've seen the video of the new thing, and there's quite a big difference at your facility, right?
Oh yeah, tremendous. The new washer is about 6 feet at its widest point wide. The length of the conveyor pod is 24 feet, where we have a 2-foot part of the conveyor belt itself sticking out of both ends. So it's got a total of 26 feet total. By 6 feet wide. That doesn't take up a lot of space at all compared to 1,900 square feet, which the old system took.
And I remember the old system it felt like it had sort of been added to over the years, like it was in one space and it expanded into another space. Am I remembering that correctly?
No, the old system occupied, as far as I know, the same space.
Okay.
Since day one.
Okay, but it was quite a big difference in floor space.
Yeah.
Mm-hmm. Mm-hmm.
And Ken, I think you've mentioned too that you're going to do additional automation on the new line. Is that true? That like the loading of the trays into the conveyor?
Yeah, right now you saw Victor, rolling the baskets into the system. We want to automate that. We want to put some sensors in there so we see the baskets come in. Actually, even shut off the aqueous system when we don't need it automatically, and so on, to save on additional energy.
That'd be great. So will it be automated that the capacitors are loaded into a tray, or does someone still load them and then the trays get automatically fed into the conveyor?
Right now we're just talking about automating the throughput through the washer. It is automated once it hits the washer. It goes from the washer, when it comes out, it is connected to another conveyor system that takes it right out to the manufacturing floor.
Yeah. Can you speak any more about Victor's experience with the new machine? You say he likes it. Like, is there anything in particular, like ergonomics, exposure, smell?
Loves it. I mean, yeah, ergonomically, before, like big units, the conveyor coming out of the old system was a lot higher than this system. So he had to use hoisting equipment to actually take the larger capacitors out, load them onto a skid, and then transport that skid out manually into the manufacturing floor. This is, we can put our big units, of course, we still have to use a crane system to load them, but we put them on there and they just go out to the manufacturing floor.
And does Victor notice a difference in what he's breathing in his work environment?
I'm sure he does. I never really talked to him about his breathing.
It'd be interesting to hear from him. Yeah.
I used to watch him work the old system, and it looked like he was really working. But this system, he just rolls it on the conveyor, and it goes right into the machine. He loves it.
That's great.
He really does. I mean, he stopped drinking and taking drugs and everything. I'm only kidding.
That's funny. So does anybody else have any questions? You please feel free to just raise your hand and unmute yourself. We've got an expert here who can share what he's learned over the years. So really, encourage you to do that.
And while we have Jim and Alicia and Haley too, if anyone has questions more about what was done with the lab testing or done with the P2 Oasis tool to evaluate the alternatives, we didn't put up the P2 Oasis evaluation of all the different alternatives that were tested over the years. That would have been a long table, but we wanted to show the comparison of the NPB versus the Aqueous that they went with in the end. But all that information is in P2 Oasis and can be compared between different alternatives for people considering different products to use.
So any other questions for Ken or Alicia or Haley or Joy?
I have one with Ken. We saw one type of capacitor. What are the bigger ones and smaller ones? And are they racked differently in the spray washer?
The larger components, they're laid down on the conveyor. Like I say, if they're very, very heavy, we'll either pick them up with a hoist, with a hook, or even a magnet. We just attach the magnet, pull it up, place it on a conveyor, and it's good to go.
And how big is the smallest ones that you would use there?
The smallest ones are ovals, about 1.25 inches by about 2 inches long. They're very small.
Any other questions?
The parts dried. I didn't quite get that part.
What was the question?
How does the system dry the parts?
Did you hear that, Ken?
How does it?
How does the
how
system
does-
dry the parts?
How do we dry the parts on the washer?
Yeah.
The tail end of the Aqueous system has a hot air dryer.
Our
that's,
videographer would have climbed in and gotten shots inside, but he wasn't able to.
no, it's a hot air blower.
And does that add that must add to the electrical
Of course,
use?
yes.
Yeah,
Of course it
yeah,
does.
yeah.
But we had all that information up front. I'm going
There's
to tell
another-
you what say it again.
There's another question here about, so you're owned by, I forget now that your new owner.
LG Electronics.
That's right. Do you think they'll share this experience with other facilities that they own? Like, is there going to be a way to share within, you know, we're sharing it with other facilities around the country, but do you think they'll share this story within other companies that they own?
I would say yes. They had their systems in place before we got our system. Our system runs circles around their system because there's a lot of manual labor that has to go in theirs. It's not a pass-through conveyor. So it's not automated. So they're putting baskets inside of tanks, taking them out, putting them into a rinse tank, that sort of a system.
Where's that?
Say it again?
Where's that facility?
We have a facility in Mexico, North Carolina, Chicago, and a few other places. I'm not sure exactly where everything is. There's a couple of places in South Carolina, actually.
That's great. We have a question for you, Ken. Do you think that this system would work well for delicate parts?
If they're too small and fragile, no, probably not, because there is a lot of volume coming out of those nozzles in the wash and rinse tanks. Even our smaller components will get moved around when we're cleaning them.
It's fairly forceful, the spray and the blower.
Yeah, it can be controlled, but we also have to clean it off too, so we can't, make it too weak.
Mm-hmm. Yeah, good
Otherwise,
question.
we have to keep it in there a lot longer.
Right. Good question. And so as a follow-up, can anyone on the call offer a solution for delicate parts?
Another type of a system, maybe more a labor-intensive system.
Mm-hmm. Alicia, Alicia, the lab has done some work with more precision parts.
Yeah, we found that higher frequency of ultrasonics can work, especially on the more delicate parts. So I would look more at the 80 hertz or the 120 around that area. They do much better with the softer metals.
So more of a batch process where you're applying ultrasonic to agitate and help the aqueous solution do its job.
Yeah, our ultrasonics normally what we test in the lab, unless if it's, as you said, precision parts that are more delicate, is normally at 40. So when we do our testing, if you happen to look at our lab testing or any of the results, unless if it specifies something specific that's a higher frequency, it's at 40, just for your knowledge as well.
Mm-hmm. Mm-hmm. Great, thank you. Any other?
I'm just going to add here, Pam, to the question about sharing the information either within their company or to other companies. This is being recorded and will be posted and shared, but we're also creating a 3 to 4 minute video about the project, interviewing Ken and showing other video footage within that. There'll be a real synopsis of the project that will go out in our newsletter and get posted on our website so other people can share that as well. And I also just want to take the opportunity to let people know that it is the season for applying for TURA grants right now. The request for proposals is out there. You can submit an application online on our website. It's a pretty simple process. Feel free to reach out to me if you have questions about your project, if you want to sort of vet it with me ahead of time before you go through the application process, that's always recommended. And the applications are due by June 25th of this year.
And I think one thing for all of us to remember is that just as you've discovered at CD Aero, the benefits associated with implementing this kind of process go beyond just the simple reduction in operating costs. And so this is a wonderful example to really illustrate what all the additional benefits to the company are. So it's a really wonderful demonstration. Thank you so much, Ken.
You're welcome.
Yeah, thanks to everybody. Thanks so much, Ken, for your presentation. The information from the facility was terrific, and thanks to Jim and Alicia and Haley as well for including your information as well. So thanks so much, and
Thanks to all of you as well.